Good morning. How's it going? Hi, Jogi. How are you doing? How's
Hello
everyone?
everyone.
It's me,
Sorry.
me and Ravi.
Yeah, hello everyone. Hello. Good evening from India. So today we are back with the second edition of ML.NET for absolute beginners, like our weekly meetup and series, where we will be talking about learning ML.NET from complete basics.
Yeah, it's gonna be awesome. We had a lot of things to cover last week, right, Ravi? We went into some of the basics, introduced some concepts, and today we're going to get some hands-on experience, I think, or you will get some hands-on experience on building a classifier.
Yes. Yes. I'm pretty much excited. First of all, I would like to say I'm sorry that I was not able to do much, but yes, I have installed the new ML.NET model builder on my virtual machine. So it's still a virtual machine, so I don't know how much it will be suitable. I still have to figure it out that how to do this ML.NET on Mac, because like it is that ML model builder and rest of the things are not yet supported on Visual Studio for Mac. So probably I'll have to use Visual Studio Code. So we'll see how it goes. But for now, I'll be using my virtual machine and Visual Studio on the virtual machine.
Cool. And I think what we're going to start with actually, Ravi, is not to use the model builder. I think what we're going to start with is building it from scratch, just using code and C#.
Okay.
And
Okay.
you can show the model builder a bit later and kind of see how that will help us.
Mm-hmm.
But I think it will give us some
Okay.
hands-on experience for sure. But I was thinking
Sure.
we can kind of jump straight into it and kind of share your screen. Or is something you want to talk about first, or can I get us introduced to?
I think uh, yeah, last week we spoke about that in order to use this ML.NET, we don't need to install anything specific. We just need to install like .NET Core along with our .NET Core payload along with our Visual Studio, regular Visual Studio installation, right?
Yep, correct. That's all we need.
Okay. Okay. So yeah, so probably we already gave the context that okay, last week we started that the plan is to create a binary classification, like binary classification plan is to do binary classification using Titanic Kaggle data. So let me first of all open that thing. So that thing, okay.
Yeah,
So
absolutely. And
yeah,
we can see your screen now.
yeah. Okay. Okay. So what I'll do, I'll some self promotion is also mandatory. Some self promotion is also mandatory. So what I'll open my channel, I'll open my channel where I have this video. Like I have shared this video. Folks, those who don't know, I am budding YouTuber. So I kind of yeah, here it is. Kind of yeah, here it is for absolute beginner. So in this channel, yeah, so in this channel, yeah, I have a description. So I have added this thing. So you can see this is Titanic Kaggle data.
Awesome.
Okay. Okay. I have this Titanic Kaggle data open. I have this Titanic Kaggle data open. Last week, and we have last week we have learning. Also talked about
Let's see. We have some.
learning sample.
1 second, Ravi. I think
Sam.
we have some echo here. I'm gonna see if what we can figure out here. Yogi, is it still an echo, or is it just is it gone now? Is it gone right now? I think it may have been your screen share as well as your microphone, Ravi. Okay, I think
Okay.
Ravi, can you speak a bit more now and let's see if the echo is gone here.
Okay, let me check. So, is the echo still coming?
We're waiting for Yogi to reply here, but you can keep talking a bit if you want to. And okay, it's fine now. Okay, perfect. Thank you, Yogi.
Okay. Yeah. So, as I was saying that this it will be like this is the machine learning samples we talked about last week that it's the better way to start is from here, like using machine learning sample, and from Kaggle we can get the samples, like, and the idea is to start with this Kaggle data.
Absolutely, yeah.
So now Yeah, so now you can guide me step by step, Alex. I'm sorry, I didn't practice much, so let's start.
No worries.
Yeah,
I think,
so
yeah, the first thing you want to do always is get the data. Get the data. So let's download the train CSV file, because that's going to contain everything we need. So if you have done it already, or do you want to do that first?
let me.
Everything in machine learning starts with the data. That's like the oil or electricity or what have you.
It's there. So this is the data from where. Yeah, this one. You were saying training set.csv. You want to download this one?
Yep, exactly. Yeah.
Training set train.csv.
Get that one first.
There is no down.
So you need to, I think, log in before you can get it.
Oh, I haven't logged in, so probably I'll have to register first.
Yes, I think so. And in the meantime, I can kind of talk a bit about what we're going to try to do here as well. While you do that, Ravi.
Sure.
I'll go back to a screen for questions for us when you do that. So what we're going to do today is look at the data, which is going to contain a couple of variables for Titanic passengers that have been there before. And based on that, we're going to try to build a binary classifier. And the binary classifier is kind of the hello world of data science, especially when it comes to data, machine learning data set. Binary classifier means you have two options, right? Either it's true or false, yes or no, died or didn't die. And that's something we're going to look at today. And there's a couple different algorithms you can use for binary classification. The most common one is called logistic regression, and that's the one we probably will try today. But some really good ones as well are so-called decision trees. So what is a decision tree, first of all? Well, it sounds kind of self-explanatory, I think, in some ways, right? It's not self-explanatory, but it's a tree. You can visualize it, and on each node, you can make a decision whether you go this path or that path. And if it's a binary decision tree, you only have 2 leaves after each node, and then you can have, of course, more than that. But for example, on the top of the decision tree, the first question could be, what passenger class was this person in the Titanic? Well, if it was in the 3rd passenger class, below deck, maybe we'll say directly like no one survived. So we're going to directly go to failed or like passed away. But if it's the 2nd or 1st passenger class, maybe we'll go to some other node to make another decision based on some other fact that the model has tuned into. So that's the decision trees in general, how they work, and it's kind of the same concept regardless of what you do. But we also have something called random forest, and random forest is more or less a lot of trees, right? A lot of decision trees. So instead of having one decision tree, you train a tons of decision trees, and you pool them together into a stronger predictor. So that's called a random forest, and that's really powerful because you can each model can kind of fine-tune its own thing. Think about the fact, if you're like 5 people and you're all blindfolded, and you are supposed to identify an animal by touching it. So maybe you go up to the animal, and like it's an elephant, for example, and you touch the elephant's leg. And by only yourself, you may not fully understand it's an elephant because you only have part of the animal. You don't know the full picture. But if you ask everyone else, someone else saying, I'm touching the face, I'm touching the back of it or something else, together you may understand it's an elephant. It's the same thing with random forest. Each small decision tree understands something of the data, and together they have a much better idea of what the outcome is going to be. If that makes sense. Alright, Ravi, have you had any luck with registration?
Yeah, I have done the registration, I have downloaded the data, and
we're back on your screen then.
Second.
That's a 2-minute commercial break here for decision trees.
Okay, so yeah, I have downloaded the data. It's there in my downloads folder.
Okay, cool. All right, let's open it up and have a look at it, I think.
Okay, so train.csv, that's I have to open, right?
Yep, that's what you want to do.
Okay, so I have opened this train.csv. So since it's a CSV file, so that's why I think Excel is opening up.
Yep, that's fine.
Okay, so we have this train.csv.
So kind of walk us through the data here, Ravi. What kind of data are you seeing? What are we looking at?
So it's basically the passenger data. We have different classification like passenger ID, whether they survived or not survived, passenger class, name, sex, age, SIB special. I don't know what is this for. SIB special, parch.
We can skip those.
So and then this ticket number is there, fare is there, and cabin is also there, and then embarked. I don't know what is the purpose of this embarked.
I think it's probably like
so embarked is also.
Yeah, I'm not sure, but I guess S is for Southampton maybe, and C is for somewhere else. Where they
Probably.
If it was multiple stops, I don't know actually.
Okay, no problem.
But yeah.
So these are the data basically, and so I think the simplest classification would be that how many survived and how many not survived, something like that.
Yeah, so I think we're going to do is build a model of predicting if you survived or not based on this data. So what do you call the survived column now? I think we mentioned it briefly last time, but it's good to recap here if you remember.
Yeah, so survived column would be our criteria.
It's almost a label. So that we call it label.
Okay, label.
Yep. So that's
label.
And what are the other columns called that are not a label? It's just a naming convention. It's just it's good to remember because it's thrown around a lot, and it's good to kind of use the same terms.
Okay.
So the other data is called features, right?
Okay, other data is features, and this one is label. Survived is label.
Perfect. Yep. Okay. Cool. All right. So I think that's enough for the data. Let's go into Visual Studio.
Okay.
So do you remember the first thing we need to do before we can start writing our model here?
What kind of project I have to?
Yep. So we can start with a .NET Core console application.
Okay, console.NET Core.
Yep. You can name it whatever you want to. Titanic, I guess, is a good idea.
Yeah, ML Titanic. I'll name it as ML Titanic example.
Yeah. And for those tuning in right now, watching Ravi Code here, this is the series of machine learning for .NET developers. We are in episode 2 here, and we are going to build our first classifier, or Ravi's. I am hands off today. So.
Yes.
Perfect.
Yes.
So that's
you are my Sanjay for today. So there is a Indian mythological series called Mahabharata. In Mahabharata, there was one person who used to guide the other person.
Okay.
And tell what to do, or see something like he there was a blind king, Dhritarashtra. So he was not able to watch the war of Mahabharata.
Okay.
So there was one guy called Sanjay who used to tell him, kind of broadcast him that what's happening in the war field.
Cool.
So similarly, you are kind of guiding me. I'm blind here. You are guiding me.
You think Visual Studio right now is a war field? Okay, let's do it.
Yeah. Yes.
Let's win the war.
I'm trying to mix and match different scenarios. Trying to bring some humor into this. I don't know.
Absolutely.
What I'm saying.
That's good.
Okay. So Visual Studio, I don't know what happened. Visual Studio, whether it started or not, it closed.
Let's have a look.
Automatic. Yeah, it got closed. I don't know. Let me see.
Let's try it again. Otherwise, no worries.
Yeah. Let me open Visual Studio again.
So while Ravi's getting Studio up and running, where are everyone from right now? How far away are you from? Anyone from India on the stream today? Anyone from the US or Europe? Where are you tuning in from? DC. Right, nice, Andrew. Andy, right? Were you joining the .NET DC last week? Awesome. Well, welcome, Andy. Kind of local. So Andy was on the meetup I'm hosting once a month this week when we're going through Octopus. All right.
Okay. Yeah, and people from .NET Core Techies group, please introduce yourself. Yeah, I mean, like, I don't know. They said that they are they have watched last week also. They said that yes, we have watched and
Yeah.
we joined and all, but nobody introduced themselves. So I don't know.
Don't be shy.
They are kind of uh, they are just using it as a background music. That okay, let Ravi and Alex be our background music
It's fine. All right.
for ML.
All right, Ravi, we are good.
Yeah. So the solution is open.
So the first thing you want to do, right, is get the dependency to ML.NET. So ML.NET, right, is a machine learning library, open source, cross-platform, and it's in C#, F#. We're going to do C# today. And the first thing you need to
Yep.
do is get the dependency. So we need to install the NuGet package here. So
Okay.
let's do that.
Let me open the NuGet. Yeah, let me open the NuGet package manager.
Yeah.
Yeah, here it is. Manage NuGet packages. Okay, another window is opened. So let me close this window.
Nice.
Space. Yeah. So
Great, yeah. Right.
Okay.
So if you write, yes, perfect. There we go. So the package is going to be called Microsoft.ml.
okay, it's still searching.
Yeah.
Okay, I wrote ML. Yeah, Microsoft.ml.
Exactly. Yeah.
This one.
Yep. Perfect.
Install.
So you can see here as well that you're going to install the basic one now, which is good. But we have multiple options here, and each of them is for a specific scenario. We have deep learning, we have fast tree, we have a lot of other different scenarios we can use here as well. But we'll just use the basic one for now, and it's going to be, I think, just fine.
Yeah, it has like CompuMat, DataView, fast tree.
Yep.
So yeah, we will be using the basic one.
Exactly, that would be good for us right now. So let's say install first. So what do you think is the next step here now when we have the dependency? What do you think we need to do, Ravi? I know it's completely out of the blue question, especially if you haven't done it before, but just kind of, we talked about the life cycle last time a little bit about the steps we need to do.
Yeah, so probably we need to load the data. We downloaded the data, so probably we need to add it into the project file somewhere or load it somehow.
Yep.
Or and then once we load the data, then probably we'll have to clean the data, or probably we'll have to clean the data before. But I think since we are taking it from Kaggle, so I think it's already clean. So we don't have to.
It should be pretty clean usually. Sometimes it's not so clean, but it should be. One thing we have problems with sometimes for Kaggle is the CSV formatting is a bit off for ML.NET. They have an open issue right now in the repo for that, but hopefully it should be fine. Otherwise, we have a backup data you can use. So.
Okay.
Okay, so if you go into the close this up, I guess close the file. We don't want that open.
Yeah, I have closed the file.
All right.
I have closed the file.
And close the NuGet Solution Explorer there.
Okay, it is done.
So the first thing we want to do, as you said, is to add the data. Thank you for the follow. Is to add the data into the solution here. So we want to go into right-click here and add existing, and you want to go and find the data. So add existing. Yep, and you find the data, the train data, and you add it.
Okay, downloads. It's in the download. It should be all files. Yeah,
exactly.
So train.csv, right?
Yep. So we add that. And then the first thing you do after you add it is actually to right-click on it and make sure you copy it always to the output folder, because otherwise it won't be able to train a model for you.
Okay, so
properties.
Sorry, yeah.
Yeah, no worries.
It's basically so I have a habit of Visual Studio for Mac. There, this kind of like on the right-click itself, it gives the option of this thing.
Okay.
So.
It's the next.
So that's
it's the next menu, I think. Copy to output directory. That.
Okay. Yeah, this one.
The one below, I think. Yeah, that one. Yeah. Perfect.
Copy always.
Copy always.
And, so I don't have to build. I don't have to give any build action, right? It would be none.
It should be none. Should be perfect. Yeah.
Always.
Perfect.
Yeah. Okay.
All right, so what we're gonna do first now we have the data in our solution, so we are we are good to start now. Yeah. So what I usually do now is I comment out, add comments to the program file on like the steps we need to do, because it allows me to keep track of okay, what is the next thing I can do here. So if you remove the console write line here, if you remove that one on line 9, because you want to be in the main method there, and just do a comment, say load data.
Okay, load data.
And then the next comment afterwards, split data.
Okay, split data. Okay, so let's do it this way. Steps.
Yeah. It's just good, I think, for everyone on the line as well on the stream today to kind of get a feeling on what we need to do today to accomplish this and when we are done, so to speak, with this model.
Yeah.
All right. And
load data, split data.
And then you want to transform the data. So transform the data is going to include converting text values to number values and so forth, those kind of things there. All right. And once you've done that, you want to train the model.
Train the model?
Yep, train the model. That's going to be step number 4.
Number 4?
Yep.
Okay.
And number 5 is going to be evaluate the model. And the last step is going to be save the model, and then we're done. So if you run this now, it's all going to work. Because it's machine learning. It's going to convert the comments to code. No, I'm joking.
No, it won't.
That's a bad joke, I'm sorry. Good.
No,
okay, so Andy asks in the chat here, what does it mean to split data? Split into known values and value to predict. Correct, Andy. I think you're on the right track here, what we were going to talk about here. So split the data means that we want to store about 10% of the data to evaluate the model on. So about 90% of the data that we have, we're going to use that on step number 4 to train the model. And the 10% that's remaining, we're going to use that on step number 5 to evaluate the metrics and see how accurate it is and those kind of things. I hope that makes sense. Does that make sense to you, Ravi?
Yeah, of course.
Cool. All right, so to get started, what we need to do here is create an ML context. So an ML context is like Entity Framework's DB context, but much powerful, I guess. And that's how all the operations is going to be there. So I would put it under steps actually, so we can kind of follow in here into the flow here.
Okay.
And you can go back to the code if you want to. I'll show you. If you after line number 9 here.
Yeah, I'm on the line number 9.
Yes, line number 9, and just press enter up there. So make a space between steps and load data.
Okay. Yeah.
All right. So you can type here var ml context, and this is not a comment. Now we're going to start coding.
Oh, okay.
No worries.
Sorry. Yeah.
It's time to get started.
Okay. Yeah. Var
ml context equals new ml context. And it's going to be, if you just type ml context and then hit control dot, you will get hopefully get a suggestion here. Let's see. Yep.
Yeah.
And then you can just do parentheses, and then if you remove the v, I guess, so make it small ml context there. All right. So I'm going to. Oh. Okay, we don't want to discard it. We want to use it, so var ml context. We need it. It's a useful thing. All right.
Okay.
So I'm going to show you a little trick here, and I'm going to explain it a bit later. But what I want you to write is seed:1 in the ml context. Within the parentheses.
Seed?
Yes, within the parentheses on line number 11.
Okay.
So you want to name parameter seed:, 1. Yes, so we're
Okay.
giving the value 1 to seed. So we're going to come back to that later, what that means. But for now, just know that means deterministic randomness. And I know that sounds a very like strange concept, and we're going to get back to that later. But for now, just ignore that. Okay, so we're going to load the data now. So when we're going to load the data, the way we can do that is by using the ML context data catalog. So if you create a variable called data, so var data here.
Okay.
And equals ML context. So if you look here, there's multiple catalogs on the ML context, and if you press hit data here, you will see there's something called a data catalog. And the data catalog is super useful for loading the data and transforming the data and all kinds of stuff. You have all the kind of methods here that you need to work with the data. So if you do, if you enter this catalog here and hit load from text file, I think, or file. Let's see where we have it. Load from text file, right? Yes, that one.
Yeah,
text file. So this is the one we're going to use here. So load from text file is going to be able to specify the data we're going to use and load it. And what it takes here is the path, and it works just fine with relative paths. So we can just say train.csv here in like a string, and it's going to be able to find it because it's right under the product right here. It also takes absolute paths, so if you have it somewhere else, you can specify it directly. It's really smart if you guys both ways.
Okay.
So there's some other things you want to specify here, Ravi. If you look at the overloads for this method, you will see there's some other options here. And there's only really two things I want us to do today. The first one is that when we looked at the data, we had headers in the data. So we had headers. And we don't want ML.net to start loading the headers, because sometimes you don't have headers or titles. So we're going to say has headers equals false here. So you can use a name parameter because it's easier. So you see that just under the cursor you have has header
equal to false.
Yeah, so we want that to be true actually. So has header colon true.
True.
Yep. And then one more thing we want to do here is we want the I think it's called character separator character. So by default it's tab separated, so TSV, but we have a CSV file, so we want to say tab separator char.
Okay, there is separator character. So
exactly.
It comes before. It comes before your.
You can put it wherever you want to. Let's use name parameters, so you can put it wherever you want to, but you can put it there if you want to.
Yeah. So separator.
Yep.
Okay.
And then single I guess what are you called?
Yeah,
yep.
Single
and
quotes.
Single quotes, and then just like that. Perfect. All right. So notice now that we have a red squiggly now, and it's not because you did anything wrong. Actually, you've done everything right. But what we did now is we actually went into the generic version of this. So there's one thing missing here still that we need to fix. Can you think about what possibly that could be?
Fix formatting. Probably, I don't know. Do I have to use @ here?
So we need to look at a schema. And before we look at the schema, I'm just going to answer Tristan's comment here. And yes, Tristan, Ravi and I are teaching ML.net live here. So we are building our first model in C# in machine learning. It's going to be a binary classifier. And this is Ravi's first time. So we are walking him through an example here. So Ravi, what we need here is like if you look at think about the entity framework, right? Entity framework, we have entities or classes that define the schema of our database, and the same kind of thing happens to be here as well. We need to tell ML.net how does my data look like. Okay. So that's what we're missing here, and if you it's going to be a generic method. So what we need to do here is create a new class for our input. So we create a new class in the solution, and let's call it passenger.
Okay.
You can do it wherever you want to. If you want to do it there, that's completely fine.
Yeah, for now, let's do it here itself.
Yeah, let's do that there. And Tristan or anyone
Okay.
else, if you like what you're seeing, follow me or Ravi on Twitch, and you will get notified as soon as we're either online talking about these fun things. All right, perfect. So yep, the curly brackets, I think.
Yeah.
So let's
So,
keep
okay.
it simple here.
So we need to give all the names according to what's there, right?
Exactly. We
So
don't need all of them. Let's keep it simple for now. But the thing you definitely want is passenger, or sorry, survived, as well as something else. But yeah, let's look at the file and see what we want here.
so let's do one thing. Let's see.
So we see here we have
Yeah, we have passenger ID. We have so this should be integer.
yes, and we don't need actually passenger ID. We can skip that. So if you look at some of these here, we can already say that which ones do you think have predictive power, and with that I mean which one do you think actually accounts for variance in the data. It's unlikely that passenger ID is going to account for anything, because that's probably something we have just added after the fact that the Titanic died. So we probably don't care about that one. But survived is important, because survived is our label. So create a property here, a Boolean property.
Okay.
And Tristan has a question in the chat here. Used MLNet along with auto detection for image classification. It didn't really work so well. I imagine I would have to build my own model. Yes, for image detection you can build your own model as well. In MLNet you can't train it with DNNs yet, but what you can do is you can train it using the Azure Custom Vision, and you can output that model as an ONNX model, which is an open neural network exchange model, and you can use it in C# if you want to. But I know that the MLNet team is working on support for training object detection models. So stay tuned, and maybe that's something we want to talk about later, Ravi and I, as well.
Okay.
All right, great, Ravi. So let's add one more column. Actually, let's add two more columns here. So we want to probably have P class as well. It's probably important. So what class they were, like if they were first class or third class, probably is going to make a difference here. So let's do that one, and let's do the sex and
P class is, I think, integer, or it's
yes.
it's
So it's an integer, but I'm gonna teach you a little trick here, so we don't make that mistake. So yes, it's definitely an integer, but it's actually not an integer. Any number in MLNet needs to be a float. There are exceptions for like categories and those things. But for any numeric value like this, for MLNet to understand it, it needs to be a float. So it's always good to just put a float there. So,
okay.
All right, awesome.
Okay, so here let me put a comment also here. Always use float for numbers.
Yep. It's one of those things you hit your head against the wall in the beginning until you understand that that's what they want. So everyone on the line, definitely do that. We'll save you some headache. All right, and then what you want to do?
I have written in bracket. I have written Alex tricks. So
yeah, Alex headaches.
later on you can make a tips and tricks video with all these tricks. So we can take out, or we can edit it out as small tricks.
Yeah.
Once our course is complete, we can take it out
all the mistakes I've ever done.
So yeah. So P class, we took P class. Then another field. Should we use name, even though it's just feature field, but for kind of identification? Or
I think we skipped the name, but what you want for sure is going to be the sex and the age here. So how old they were and what gender they were. Because if you think back when this was happening, children and women were the first one to be on the lifeboats. Usually there was that kind of courtesy. So I would say that children and so younger individuals and females probably would have a higher likelihood of surviving because they were on the lifeboats before the male. So that's something that we probably want to look at. So it's always good to kind of have an idea of the data, of course. You can always try every feature in the beginning if you want to. There's nothing hindering you from doing that. I'm just giving
Mm-hmm.
you some thoughts here as we've done this before.
Mm-hmm.
All right.
Okay.
So that's good. So the sex is going to be a string actually, because it's I think it's
Yeah.
male and female, right? I think so.
Yeah. Yeah. It's just male and female.
Okay.
Yeah. It's string.
Cool. So you're almost done with the schema now. The thing you need to add here as well is an index.
Okay.
So you need to have something called a load column attribute, and that's going to tell ML.NET which column index in the CSV file this data is coming from. So on the survived,
Mhm.
if you decorate the survived property with hard bracket and then load column.
Okay.
Uh,
Load column.
Yep. So it's just spell out load column. So capital L and capital C. Load column, and then hit Control dot to find it. Yep. And Control dot. Perfect. Enter. And then you do
Okay.
0 here, because this is the oh sorry 1 I think, right? This is the second column. And
Yeah. Survive is second column. So what I have to do, colon or something? How load column, and then what I have to do? Just
give the index of the column. So this is going to be the first column. So it's 0 index. So 0 is going to be passenger ID, right? Because that's the first one. And survived is going to be number 1. So 0, 1.
Mm-hmm.
So this is going to be parentheses.
Okay. Parentheses.
Yeah,
Here's
parentheses. So it's a constructor.
1.
And then 1, yes, in between. And then remove that space between load column and parentheses. Perfect. So what you, if you add the rest of those load columns to other properties, I will answer some questions in the chat in the meantime.
Yeah. Sure.
So
load.
yeah. So Tristan, I think the reason why they want float is because what we want to do in the background, or what ML.NET does in the background here, is it converts all of the numeric values to float vectors. So it span up a space, a multi-dimensional space with float vectors, and it's the fastest thing to work on. So I think that's why we're using floats here, but don't quote me on that. And S said YYY is asking about how to describe karma in code. That's a good one. Return 1, return. So what? Can't you just have bad karma and good karma, or is it something in between? Is it more than 2 options?
What? I didn't get you. Is it something?
Yeah, it's a question on
Someone is.
question on the chat. How do you describe karma in machine learning? And I was wondering.
Okay, you. Okay, so see, karma comes into basically. See, I'm also an astrologer, so I can say that karma comes into. Ideally, if you see religion-wise, it's always said that it comes in black and white. That is bad karma and good karma. So it would be, of course, binary classification. But if you think practically, you have to think about that. Like what is bad for you, sometimes it can be good for someone. So you have to see from their perspective also. So you can say that it doesn't comes into the binary classifier. Then it probably will have to use some different classification, because it would be like bad karma, good karma, and then bad according to them, bad according to us, good according to them, good according to us. So that way. So you have to one 0, 1, and then your variable thing.
So that sounds to me like a multi-classification for anyone on the stream today.
Yes.
So we're going to talk about that, I think, in the next episode. But that's multiple options instead of binary options, and that's completely doable and pretty straightforward. And just to answer the final question before we move on, Andrew asked if this is the load column is 0 based, and yes, it is 0 based indexing. And you can also actually specify the load column name if you want to override the name as well. But for us, it's going to be fine as it is. All right, Ravi, on to you again.
Yeah, so I have given the load column names, and I think we have to give this class somewhere in this constructor of this.
Yes, so we're going to use a generic argument, right? So we're not going to use the constructor, but it's going to be a generic argument for load from text file. Exactly.
Okay, so here.
Yep. So put in passenger there.
Yeah.
So So that's going to tell
Okay.
MLOnet that this is a type I'm expecting, and ta-da, it's working.
Okay. Yeah,
All right.
it's gone.
So this simple line here is going to load the data from the CSV file, and it's going to know the schema, and it's going to know to skip the headers, and it's going to know it's a comma separated file. Perfect. We are good to go here.
Okay, so
That's done.
this we have done first step.
Yes. How does it feel so far?
Okay. Yeah, it feels easy.
Good. All right. Just know it's a very repetitive process. So most models, there are some exceptions of course, but most models follow the same flow. So once you know the flow, you will at least feel like you have something to anchor yourself to. It's like, okay, I'm not sure exactly what to do now, but I know the next step is splitting the data, you know?
Yeah, right.
All right, so split the data. So we're not going to do this manually. There are, of course, built-in methods. So what I usually do here is I name a parameter or a variable called test train split. So you can create a variable called test train split here first.
Okay. Test train split.
And it's going to be equal to ml context dot data.
Okay. ML context the variable.
Yes, the one you created. Yep. Dot data. And if you look here, what kind of methods do you have available for you here? So hit the dot here, and you'll get some suggestions. And let's look at them. Which one do you think you would use here to split the data? I hope it's here.
So okay, yeah, cross validation split is there.
That's not
Number one is this.
almost, but not the one we want. Keep going down. Let's look.
Shuffle rows. Yeah, train test split.
Yeah.
At the bottom.
Nice name, right?
Yeah. Okay.
So let's look.
Okay,
What do you pass in here?
Okay, so it says that test fraction string. Okay, it has only one. It doesn't have a overload. So it has only one method. It says test fraction double and then
Yeah.
sampling key column name.
Yeah.
And then seed.
So we can skip all of those fun stuff here, but it seems like the only thing we really need is a data view. And when you load something into memory, what you did just above, it loads into an iData view. So it's an interface we can use. So you can just pass in the data here, and that's all you need to do.
Okay, so what I have to write? Just pass data.
Yeah, the data you loaded is going to pass in here. And as you saw in the overloads here, the default split value is 0.1, and that means that the test data set is going to have 10% test data, and the train set is going to have 90% test of the data. Okay, so if you the object is passed back has two properties. So if you create a new line here and create a test data variable, just so we can look at that. And you use the test train split, and there's a property on that object called test train data or test data. Yep.
Test set.
Yep, exactly. So enter there, and then create a new variable called train data, and use the train data on this split instead. So that's how easy we split the data into a way. So let's think about what it's doing here, right? So it's randomly splitting the data. So I'm going to go back to discussion now about the seed value. Why do we have a seed value? So think about what happens. So let's say we actually create this whole flow here. We have the low data, the test, we train the model, we transform, we evaluate, all good. But what happens if you rerun the training every time? If you like hit F5, train a new model, and then train a new model, and train a new model. If you don't have a seed value, what's going to happen is that every time you hit the train test split method, you're going to have a new split, okay? Which means that you're going to have different data in a train set and different data in a test set. So what does that do? Well, what happens then is that if you have different data to train your model on, it also means you get a different model. Right?
Right.
It's pretty straightforward. Like if it trains on a new set of data, it's going to learn something else. So the accuracy is going to be different, and the model is going to be different. And we don't want that. Like we want it to be repetitive. We want to control when it changes. It should only become better or worse because we change the algorithm, we change the data in the behind, or something else. But it shouldn't get better or worse because we retrain it like that. So what C does is to say, okay, please split the data randomly, but do it randomly the same way each time. Do you know what I mean? Do you want to say?
Okay.
So like split the data randomly, but if I repeat it, do it the same random way every time. So that's what, when we talk about deterministic randomness, that's what we're talking about. It's a kind of a strange concept, and you don't really need to think about it too much. The only thing you need to remember is always add a seed. That's the only thing you need to do, and you'll be fine. But I wanted to explain the concept a bit.
Okay, I have added it as a note here also.
Okay. Yes, Tristan, this is going to be on YouTube. It's going to probably be on both Ravi's and my YouTube channels as well.
Yes.
And it will also be on Twitch for, I think, 2 weeks or something like that before it goes away.
Yeah, and along with that, I'll also be sharing this link, and I'll be checking in this code also. It will be available on my like my Techie Rathor GitHub account. So
Awesome.
you can take it from there. So you can download it and all. So it will have all the links and everything. So I'll try to create an extensive README file.
Yeah.
By the way, I'm Techie Rathor everywhere. Just self-promotion.
Yeah, good. Let me add some links in the chat here while this is going on, because it's important. So, what do you think is the next step now? Now we have split the data. What do you want to do after this, Ravi?
So we have one like sex as string column. So probably we need to transform it as like the third step is to transform the data. So do we need to transform the data to like text to number and something?
Exactly. So now we want to create our transforming pipeline here. And you asked to create something in ML. You want multiple training and test sets. I think, is that easy to accomplish? You always want one training set. The training set can evolve with time. So when we train the first time, that may be different data, but then you may enrich that data with more knowledge and more information. So definitely the training data set can improve, but you only want one per model. And then test set, I think what you're thinking about is something called cross-validation. And that means we can fold it into 5 different folds, and we evaluate the model in 5 different small test sets. And that's a very good technique to use if you have very little data, or if you want to make sure that you don't have skew data. And we'll definitely go into that in a different episode, I think, as well. And great question. And Tilu is asking you, Ravi, if we need to clean the data. And that's actually a good question. So when I say transform, I also mean clean.
Okay.
You can put that in there if you want in the comment, but transform and clean is like a bucket for me.
Okay.
All right. So what we want to do here is create something called a data processing pipeline. I call it a data pipeline. So create a variable called data pipeline. So everything in ML.NET is about just chaining transformations on each other. So we're going to chain some transformations on each other right now, and then we're going to chain some algorithms. So again, where do you think you'll find a transformation, Ravi?
Transformation.
Like where?
Again, probably it's in ML context, of course.
Yes, exactly. Everything is in ML context. So
yeah, because context is everything.
Exactly. Good one. So in this time, we don't want to use the data catalog. So what kind of catalog do you think we would use for transformations?
Probably transformation catalog. Yeah, transforms.
Ta-da! All right, perfect. So do that. So let's think about what do we want to do first here. So what kind of columns do we have?
I think we have we have one Boolean column, one float column. Two float columns, one Boolean column, and one string column. So probably we need to. Do we need to transform this Boolean also? I think we don't need, right?
No.
It's anyway bit.
That one is
0 or 1. So we don't need to do this.
Exactly. Yeah.
So probably we just need to transform this sex.
Exactly. So
Okay.
that one
Yeah.
is the kind of the thing we want to do here. And can you open up the data file again, just to look at it real quick here, to get everyone on the stream
Yeah,
familiar what
sure.
we're doing.
Okay. So I'm opening the data file in the raw format,
That's fine. Yeah.
just so because it was like this takes Excel takes a lot of time in loading, so that's why
Yeah.
I'm opening it in.
So let's look at the. I'm going to point up here. Let's look at the data here. So one thing you see here, right, is the sex column is not a 0 or a 1, right? It's a male or female. So
Oh, okay, yeah.
exactly. So rule number 1 in machine learning, and this is important. Same thing with like the float thing, is that machine learning cannot work on anything that's not numeric. It needs to be transformed to a float vector. Okay, floats or just
Okay.
numbers. So when we have like male female, it has no idea what to do here. We can't work on that. So what we need to do is transform it to a numeric form. And depending on the use case and depending on how the data looks like, that can be done in different ways. In our case here, we only have 2 types of data. So the cardinality of this column is 2. There's only 2 types, male or female.
Right.
So the way we do this, and we're going to do this, is using something called one-hot hash encoding. Or actually, one-hot encoding.
Okay.
So what is one-hot encoding? It's a kind of interesting concept, and I'm going to try to explain it. And definitely ask me questions about this, Ravi, and let me know if that's making any sense. But we want to translate male and female to numeric values. The easiest way to do that, the absolute easiest way to do that, is just saying, okay, male is 0 and female is 1, right? That's like the easiest way of doing that. And that's called labeling, and that's definitely a technique we can use. It's like pretty common and definitely useful. But there are some drawbacks of doing labeling, and one of the drawbacks is that an algorithm is very smart. It's very smart, so it doesn't know if 1 is better than 0, right? You can't really say is 0 better or 1. Like usually, like the higher the number is, the better it is. So it may make assumptions about the order that we don't want it to make. So labeling is a little bit difficult and dangerous to do if you don't want to. So what we're going to do instead is something called one-hot encoding. And what that does is that it takes that column, the sex column, and it adds 2 new columns instead. And the first column is going to be called is male, and the second column is going to be called is female. And each of those is going to have a 0 or a 1 in it. So if we have a male in the value, the is male column is going to have a 1 in it, and the is female column is going to have a 0 in it. And then the sex column is going to be dropped. Does that make sense?
Okay, but won't that also confuse it later on? It's being when the algorithm does this thing, so they do it automatically, randomly.
Exactly. And the good thing is that it doesn't have a size, so it's going to be a binary column, which means that each column is going to be treated the same way. And that's something also we should talk about later, is that we always want to normalize our values. As long as our values are in the same scale, it's always going to be a better model. So in our case, we just want to normalize them to make sure they are appropriate. Cool. So anyway, a long story short here, it's not so difficult to do that. What you want to do here is do one-hot encoding. Transforms.one-hot encoding.
Okay.
There should be a method available.
Where is it? Okay, I'm writing one.
Sorry. It's actually in something called categorical, I think. It's a subcategory here. So categorical. Transforms.
Okay, sorry. I thought directly.
No worries.
Transforms dot categorical. Yeah, categorical. Yeah, here it is. Dot. Yeah, one-hot encoding.
Yeah, exactly. Yeah.
So what is the difference between this one-hot encoding and one-hot hash encoding? Is it something like? Let me try it out. Is it something like that? It kind of like encrypted or something like that?
So the difference here, and I may be wrong here, but I'm pretty sure this is what the difference is. So let's think about. Right now we have only 2 values, right? But what if we had 1,000 values? what happens then? Or let's say 10,000 values. What's going to happen then is you're going to span the data set to 10,000 values. And that's going to be a very wide data set, and it's going to eat up your memory. So you're going to get out of memory exceptions. And you get something called a sparse matrix. And I think what one hash encoding does is that it handles that sparse matrices issue, and it doesn't kill your memory footprint. So it's going to make sure that it's smarter and kind of compose down your large data set to something much smaller for you. So I use it usually when I have a very large data set or like a lot of values in it.
Okay.
Okay. So what do you want to pass in here? Let's check the input variables of this method.
Okay, so it has two overloads. The first one contains input-output column pair, and then output kind.
Yep. So what you want to do here is
output kind. Yeah, go ahead.
Yeah. So the only thing we actually need to pass in here is the name of the column you want to transform here.
Okay, so it would be like in string or?
Yep,
yeah,
exactly.
It would be string.
And what I usually do here,
so
like a lot of examples, is like just a string value. We can do that for now. And what I usually do is do like name off, and I do the schema class and then the property name. So if you change that, it's gonna kind of not break the model.
Okay.
But that's fine. Okay, so we have
schema class, then property name. Give
Yeah.
me the syntax of that. Probably
Sure.
I'll do that.
So let's do name off. If you do
Okay. Oh, got it.
exactly, yeah.
Dot name off.
Yeah, it's just it's always tough when you have like hard-coded strings in your models.
Yeah, I agree. Name off. Sorry.
No worries.
It will be just name off. Yeah, name off, right. And then this would be passenger dot 6 and this. Okay.
Nice, perfect.
Yeah.
Okay.
And anyone on the stream, if my text is like small, just let me know, because I think both me and Alex, both of us are directly watching on the screen. So like for us, it's coming as normal. But if someone is looking on the larger scale, probably on Twitch stream on the left side also there is something, on the right side also there is something. So if you think that text is small, then let me know. I'll increase the text.
Cool.
At least this one. This one I can increase it right now. For this one, I have to change the property, so I'll leave this.
It's
one
fine.
later.
I think Andy just mentioned it looks good on the chat here, so that's awesome. Thank you for the input.
Yeah.
All right.
Yeah.
So the next thing we want to do here is that we have we want to look at the age column, and right now I'm going to just simulate an example here. Tristan says that he keeps hearing a steam train expelling air every few seconds, or steam, which is fine. Don't worry about it. It's funny. Steam train. All right.
Okay. I think there is a whistle in the background. It might be coming in from other room. My wife is cooking something.
No, it's completely fine. It's kind of funny. That's the world we're living in. I thought it was funny. It was a steam train. All right, yeah. Ravi. So what you want to do now, and I'm going to simulate this example because it's not really an issue, is that let's imagine that we don't have the age of every person on the chip, right? So in the data is going to be missing some values. We may not have the age of every person. So we need to do cleaning then, right? Just like Tilo said earlier in the chat here. And what we can do then is append transformation. So if you on line number 23 here, after passenger 6 here, if you remove the semicolon,
okay,
and then remove the semicolon, new line. So hit enter, and then do dot append.
Okay. Yeah, dot append.
Yep. So you can see here that everything is a chain here. So we can do method chaining when it comes to ML.NET. And what we want to do now is we're going to append a transformation for cleaning up the age data. So again, it's going to be on the ML context in a transform catalog.
So we have, so transform, so it has like, okay, dot append, and then in dot append I have to give again ML context.
Exactly.
Transform, right?
Yeah. So we're appending a method here, a chain. So we're doing ML context dot transforms, and then what you want to do here now is we want to replace missing values. So do you have anything that's called replace here?
Yeah, replace missing values is there.
Yep, perfect. So what this does is takes a lot of arguments, but there are only two that we care about. The first one is going to be the name of the column we want to look at and replace missing values in. So what column is that again?
That would be age.
Yep, exactly. So let's do the same.
Yeah, so probably, yeah, we'll do the same thing, that name of this thing.
Perfect. And anyone watching on the stream, I have 47 followers right now. I'm going to do self-promotion here. I'm 3 followers away from affiliate status. So if you don't follow me yet and want to make me happy, you should hit that follow button and make me very happy.
Oh yeah, yeah, of course. So you need 50 followers for getting that affiliate status?
It's one of the criteria at least, yeah.
Okay.
All right.
Okay.
So perfect. So
Yeah.
one thing here. So what we can do now is you do a comma in the method. The second parameter we want to look into here is how do you want to replace these missing values. So we have something called
so replacement mode they are saying.
Yeah, so use a name parameter here called replacement mode. So if you do replacement mode, I guess it actually is the next one anyway, so it's fine.
Yeah, replacement mode it's the next one. Yeah, that's fine.
Yeah.
So, and it's in enum, I guess. It's in enum.
Yes, it is. Thank you, Tristan, for the follow, and I think someone else has followed. I appreciate that very much. We're 2 away now from 50 followers. Yes, hit enter, Ravi. Hit enter here.
Replacement mode.
That one, yeah.
Hold for a sec. Just replacement mode. Where it is? Replacement mode. There is.
You can just
this one.
Yep,
Yeah, right.
Yep, hit enter.
Got it.
And
dot default value.
Exactly. So look at what we have here. So what we can do here, let's say we have a missing value on the age. We don't know the age of the person. And if we don't replace the values, we don't clean the data, it's going to create a very bad model because there's going to be outliers in the model. And we don't want that.
Right.
So you want to, so we can define how we want to do that. What we can do is we can either replace that value with a max age in the column, the minimum age, or the average age. So I usually do the average or the mean age because that usually makes the most sense here. So mean is, I think, usually a good option here. So what that's going to do...
Mean, or I think minimum, we should take it by minimum age.
Yeah, we can do whatever you want to. I usually do mean, but minimum is fine. Let's try that.
Like, just wanted to know, like, you take mean because, like, it should be the mean of all the people, so that we have that we are kind of a you can say a balanced data set.
Exactly, yeah.
So, to make it a balanced.
Yeah.
Okay.
In a real world scenario, we would have done some more complicated stuff here, but for now it's going to be just fine. But in a real world scenario, what we would have done is we would have taken a look at that person with a missing age and say, okay, is he female or male? Okay, he's male. Okay, good. What passenger class is he in? Okay, first class. All right, so what's the mean age of every male in first passenger class? That's going to give you a much better indication of what age is supposed to be.
Okay.
But
so we might have written some function for that thing and then call that function.
Exactly.
Here,
That would be like the data science accurate approach. But for now, this is a good way of doing it. So I think what you're missing here is just a name parameter. So on the first thing on line 25, you want to add replacement mode as a name parameter. Because I think right now it's in the wrong order otherwise. So
yeah, here.
Yeah.
I think. Replacement mode colon, like this.
Let's see. Yeah, perfect. I think so. Large M, right?
Yeah, like no, I added it.
I think it's
Yeah,
small
large M.
r, I think.
Okay.
You want to do that.
Yeah. Yeah. Done.
Okay, perfect.
Done. Yeah.
All
Now
right.
it's gone.
Nice. All right, so we're almost there now. We're almost there. So the last thing you want to do here is, because now we have done is we have transformed the text column to binary columns. We have replaced our missing values in the H column. So what we want to do now is append the last thing. And the last thing we want to append is grouping all of our features together into a feature. So do enter again here and hit append.
Okay. Dot append.
And then again, you want to go into the ML context.
Dot.
And
Trans.
yep, transforms is fine. And you want to go into something called concatenates. So by default, you're not going to have all of the columns. Like just because you define them in the schema, it's not going to mean that you're actually going to use them in your model. So the last thing you need to do here is define which ones of my columns am I going to use when I train the model, right? So what we're going to do here first is we're going to. So what's going to happen is that we're going to take these columns, like the sex and age and passenger class columns, and we are going to create a multi-dimensional features vector. And it sounds kind of sci-fi a bit, but all we need to do here is define two things. The first thing we need to do is define the name of the features vector, and this is also a trick to say. Always call it features. So what you want to do here is you want to so concatenate is a method, and you want to type parentheses here, and then you want to type in quotes features.
Sorry, your voice broke. So concatenate, then
Yep.
inside this.
Concatenate and then features.
Okay.
So what we're saying here is that what is the output column name? And the output column name is
Like this?
yes, with a capital F. So why am I calling it features? Well, you can call it whatever you want to, but features is going to be the default name. And if you call it something else, you have to override a lot of methods to make sure that the name aligns with this name. So that's why we're saying features is the name of this column here, just so you know. Okay. So the next ones here, the what this method takes is a number of strings. So what we need to feed in here is the name of the columns we want to include in this prediction. And there's 3 columns, right? It's P class, sex, and one more thing, I think, right? Age, yeah.
Age.
So I think for now.
So
yeah, for now you can probably just pass them in as strings for now. Just make it simple for us.
okay.
So let's pass them in there.
So like this?
Yeah, actually, each one of them is going to be its own own string. So P class is its own string. So it's going to be a parameter of strings. What do you want to do?
Okay. If it is like that, then probably we can use name
you can if you
of.
want to. It's mostly like just easier and quicker, but you can definitely use name of if you want to.
Yeah, but anyways, let's go.
Okay. So what you've done now is you have created your transformation here. So we have a data pipeline. So you're done with the transform step here. So good job, Ravi. Applause. All right, good job. So now we're going to go into the machine learning stuff here. Now we're going to train the model here.
Yeah.
So what you need to do here is everything in this framework is appending things to each other. So you're going to append things to this pipeline. So you're going to create something called a training pipeline. So create a parameter called training pipeline.
Are you listening some happy birthday sound from my background?
It's fine. We all have lives.
Yeah, one of my nephew has birthday, so like my wife is calling him and wishing him. They are
Good,
celebrating theirs.
Well, congratulations to your nephew. Happy birthday.
Yeah, thank you.
All right, so
Yeah, training pipeline.
yes, I'm going to ask you a question from Tilo on the chat just real quick here. You don't have to worry about, so he's asking, how do you decide the order of the column names in the concatenate method? There's no order. You can define it completely as you like. You can put them in age first or sex first. It doesn't really matter. It's going to be the same. But good question.
Okay.
All right, so
Yeah, probably we can write it down here that order of fields doesn't matter in concatenate.
Exactly. Just fine.
Okay. Yeah.
Cool. All right, so
So
next step, Ravi, it's going to be to append a trainer on top of the data pipeline. So we'll take the data pipeline first here.
dot append.
Yep.
Yeah.
So you see this pattern here where we chain things on each other. We chain transformations, and now we're going to keep chaining a trainer. So where do you think this is going to live? It's not as easy, but I'm just going to see if you can see it. It's not very obvious. So ML context is definitely correct. So that's a good start.
Okay. So transform data forecasting, binary classification, training. I think when we are doing this thing, regression, so transform. Yeah, so I think whatever algorithm we are using, so it might be in there. So we do it the binary classification dot something like training or something like that.
So when we start,
trainers.
Exactly, yeah. So when we start talking about appending a trainer, you'll find those things in your ML task catalog. And ML task is, I think we talked about it last week a bit, but ML task is, I guess, different things you can do. In our case, we're doing binary classification, so we ask 2 values. If you want multi-classification, it will be under a multi-classification catalog. And if you do forecasting, it'll be there. So you will kind of have them grouped together. And then for your algorithms, they'll be under the trainer. So you are exactly on the right spot, Ravi. So great job. So if you hit enter, or if you hit dot now and look at what you have in this catalog, what kind of options do we have here?
We have average perception, field aware factorization machine.
A lot of stuff, right?
Linear. Yeah, all of these are gibberish to me.
Exactly, and for most people. And
in Hindi we call it as kala akshar bhais barabar. So the literal meaning is like black words look like buffalo.
Okay. So well, they're definitely difficult to understand. And now we're dipping deep into the data science world right now. So what you're looking at is different algorithms for us. And in different packages in NuGet, there's also additional packages we can use, like fast tree, decision trees, those kind of stuff. But these are the default ones. And don't be scared of these. Like, they sound very complicated and they sound very strange, and some of them are. But what we can do here is just take one and try it, and then if it doesn't work or it gives us a bad model, we'll try the next one and we'll see how good it is. And you can just kind of iterate over this until you find a good model. But the one I always recommend starting with is logistic regression. And it's halfway through the list here. LBF, yep.
Okay, LBF.
Exactly. It's called
logistic regression. So why this? What does this LBFGS? Why can't they just
I think
name
it's a type
it
of logistic regression. I think it's a good question. but we're going to use this one. It's the simplest one when it comes to what input we need to do to it. So that's why I like it. So the only thing this one really takes here is which column we're going to try to predict. All right. So what is our label? That's the only thing it's taking. So you need to know what is a label. What is the thing we're going to try to fit our data around? So what is our label, Ravi?
Okay. So our label is the survived column.
Exactly.
How many people survived? So it would be like, so this would be like name of like this.
Yeah.
Copy here, paste, and this will be survived. So come on, survive.
Nice.
Yeah, here it is. Survive.
Exactly. Yeah. So that's all that it's taking, and I think you may need to fix your parentheses. No, it's good. Perfect. So that's going to append the trainer.
Yeah.
So now you have a data pipeline, transformations, split the data, you have a trainer. So you're actually good now to do the final magic words. And the final magic words is .fit. So you can create a variable now called model or trained model, whatever you want to call it. But this is going to be your model. So trained model. Now we'll get into the fun stuff here.
Okay. Okay, trained.
And the trained model is going to come from the training pipeline.
Training pipeline.
And let's see. Exactly.
Fit.
So what are you going to pass in?
And
yeah. So what are you passing in here?
There's
one thing missing.
Okay, let me check. I think it would be whatever value is fit. So probably it would be the passenger class.
Almost. So what are we going to? Almost.
No,
let's think about it a bit more. What do you need to train your model on? What is the oil or electricity of machine learning? The model is going to be output, but what do you need to get a model? So the training process is going to data, exactly.
Data.
And Tristan had the right answer as well in the chat just now. So data. So we split the data already, and we want it to be the train data, right?
So it would be probably data pipeline dot output data
simpler.
Or something like that.
If you look at line number 21, what do you have in line number 21? Exactly.
It's train data. Yeah, so it would be train data.
And Satya has also the right answer. Sorry if I misspelled or mispronounced your name.
Okay.
Thank you, Tristan. I appreciate the compliment. Tristan said I had a lot of patience, and he was wondering where I was in college. I don't know.
Okay.
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 All right.
Yeah.
So train data. Perfect. So now you're gonna have a trained model. It's great, right? That's great. And it is. Some people will say here that okay, we're good. We have our model here, and we can use it. But without the last two steps, it's kind of pointless. So now we need to figure out how good this model is and how good the data is. So the last step is going to be evaluate. And what you want to do here is okay. Let's think about what you want to do actually. What do you want to do when you evaluate something?
So we check like we test that evaluation is kind of like testing that whether the model which we have got is correct, like giving us correct result or not. So probably we can do like we can evaluate this trained data with the test data, that whether this thing is matching or not.
So we want to take our model, we want to transform our test data, and then we want to calculate the metrics based on that. So there's kind of two things you want to do here. Let's see. What we want to do here is first of all transform your data. So what it's always hard to explain this part. I'm gonna try to explain it. But what you want to get here is predictions first, and then after that you want to get metrics. So let's write the code first, and let's walk through it afterwards. Does that make sense? So let's do a variable called predictions here.
Okay. prediction. Okay.
Yep.
Predictions.
And then that's going to be train model dot
Okay.
transform,
Train
I
model.
think it is. So transform is a
transform is
method you
there.
can use on your train model to transform data that you have. And so in our case, we want to transform the test data, right? So pass in a
Right.
test data set here.
So
It's going to be a method, so you can just have a
and
parentheses.
then test data.
Yep, test data.
Yeah. Parentheses. Give
Exactly,
test data.
and it's saying compare predictions against actual test data. Exactly. So what we're getting back here in predictions is two things. We're getting back, so it's going to look at each passenger in the test data. It's going to say, okay, Mr. Smith or whatever, he survived or he did not survive. So it's going to give us a prediction. But in addition to prediction, what it's also going to give us is a score. So it's going to say, okay, Mr. Smith did not survive, but I'm only 60% certain. And then Mrs. Smith survived, but I'm only 80% certain. So nothing is black and white in machine learning. It's always a gray zone. So with that score and that prediction, we can calculate something called metrics. And that's going to give us how accurate the model is. So we can add a new line here and create a parameter called metrics here. And that's going to be, so every machine learning task has a different kind of evaluator. So you'll find this on the ML context of binary classification. So ML context. And we definitely won't get 100% accuracy here, but we'll get something decent.
ML contact of binary classification dot.
So evaluate, right? I think it's called evaluate.
Yeah, evaluate is
so
there.
evaluate. So every time, so this is just an example for binary classification. But if you do multi-classification, it's going to be kind of the same thing. So you have like the evaluate method, which you can use to check the performance of your model. So what are we passing in here? Let's look at that.
Predictions?
Yes, exactly. Predictions. So passing the predictions into this one. And then one thing you also need to pass in here is a label column name. So it needs to understand which column of the data or the predictions are we going to try to calculate the metrics from. So just like you did here for the trainer, you pass in that as well. Nice. All right. So that's good. So we're almost done. We're going to add one more line of code, and then we are going to run this. So the last line of code we're going to do is save the model, so we can use it. Because if it's kind of fun to do this, but we need to use the model, and it's going to be saved as a zip file. And when we're going to load it, it's going to be loaded as a zip file. So again, you'll find these things on the ML context. It's going to be ML context, and let's see if you can find where it is. It's going to be under a new catalog that you haven't used before. Yeah, maybe.
Will it be model? Let's
see, what do you have? Yeah, exactly. So save is going to be to save it, and also on the model catalog you have load, which is going to load it. And this one takes two things here. Actually, it takes three things. The first thing you want to pass in is the model, right? So the train model that we want to save.
Okay, so the train model, that is this one.
That's what we want to save, and it's going to end up being a zip file. The second thing you want to pass in is a schema. So you need to pass in what kind of schema we're looking at here. So like, for example, if the schema changes, it's not going to work. And the schema is going to be found on the, for example, the train dataset. So if you look at the train dataset.schema, I think it should be there.
Okay, sorry.
Yeah, I know.
Okay, so I
No worries.
I thought old habit of using thinking that schema means the class file. So
it probably would be a good improvement instead, like type of passenger. That would make more sense, I think. Alright, so train data.
Okay, yes. Train data dot
Exactly.
schema. Yeah,
And the
there it is.
last parameter, what is that?
It would be the
Exactly.
zip
File
file
name or
name.
path. If you just put the file name, it's gonna save it locally, like where the binary is, which is fine for us right now. So you can call it whatever you want to.
Okay, so let's call it as train model. Okay.
Good. Are you good? Feel good? You're done.
Yeah. Okay.
Yeah. So what we're gonna do now?
Okay.
We're going to run it and see if it works, because it may probably blow up. Honestly, I'm not sure. We definitely may have issues here.
Let's see.
So what I want to do is you put a breakpoint on the fit method, because everything else is gonna go pretty quickly.
Okay.
And also there is fine, yeah. Actually, put
Okay.
a breakpoint right there in the beginning, and we'll kind of debug it locally.
Yep. That's what I'm thinking. So, and then your method.
Yeah. So if you hit F5 now, or just run.
Anyways, when you're debugging it. Okay, just run.
Yes. And we'll see if this works.
Okay. It's
Hopefully it does.
going through it. Okay, let's see. It's building.
Awesome.
Build succeeded. So it's good that we don't have any
At least not
index
yet.
error. ML Titanic
So
EX.
Andy has a question here, real quick.
Yeah.
The model saves to a zip file, Andy, and it's going to be saved in the bin folder. So it's just a console application, and it's going to run the .exe file, and it's going to save the model as a zip file in that folder. Actually, oh, good question, Andy. Ravi, you need to have .zip as well on your model, on the file name.
Okay, I need to have dots.
Yes. So let's stop this and put .zip there.
Is it mandatory? Like, won't it add it automatically?
We can try if you want to. I don't think it will add it automatically.
Okay.
I mean, I think you probably can call it whatever you want, honestly.
let's. Okay, let's run it for now. So we have hit the breakpoint. So F10.
Let's see, I think at least screen first for me at least here. Let's see. Let's give it a moment. Is it hitting your breakpoint?
Okay, I'm on test data.test.
What?
Yeah, it has hit my breakpoint.
Let me see. I think we're
showing test data.test train.
let's see. I think your screen share it froze a bit here. Because I can does.
Okay, should I stop?
Let's see.
sharing?
Does anyone else?
Let me stop sharing
Okay,
and share
sure.
it again then.
We don't want to miss this important thing here.
Okay, can you see now?
Yeah, if you shared can't see it yet.
I shared it
Okay,
again.
perfect. Thank you, Ravi. We see it now. All right, it's a live stream, guys. This is what happens on live stream. It's great.
Yeah.
Okay, so
Okay. So I'm
okay.
on this
So
test
keep
data.
hitting F10 there and keep walking through. So you can keep going if you want, all the way to fit if you want to. Hopefully it won't
Okay.
blow up before then.
Okay. So fit
Okay.
took some time. It didn't blow up. It moved ahead.
All right, so perfect.
Yeah, it moved ahead.
Okay, so let's go past the matrix.
It's done.
Okay. Stop on the save call here.
It's done.
Okay. Did you?
Oh, okay. I
Yes.
moved
Did you
ahead.
already stop the debugging?
Yeah, the debugging is stopped. So let me do one thing. Let me go on the output
sure.
and see.
So what we could have seen here as well would have been the metrics,
Okay.
and the metrics would have shown how good the model was and the accuracy, and would have shown the something like how accurate it was and Epsilon score.
Oh, okay. So we can run
Yes.
it once more, and this time what I'll do, like, we won't go the whole thing. I'll just put a breakpoint here
Yes,
at
put it-
matrix. So once it hit this breakpoint will move ahead to this last breakpoint. Sorry, on the save
Exactly,
I'll
yeah, put
put
on
the
save.
breakpoint. Okay, so I'll put the breakpoint here at the save.
I think that's good.
Okay, so I have put it on save. Yeah, it's here, F5.
So
Okay, it's calculating,
yes,
I guess.
perfect. So let's
Yeah.
hover.
Okay.
Now we can see
Now-
it. See it, Ravi. Great. So let's hover over matrix here. It's called metrics, but it's fine. And open up the different options we have here, so we can
Okay.
see what you have here.
Let me. Yeah.
Nice, thank you. All right. So what
Okay. So
walk
we
us
have.
through what we're seeing, Ravi. What are we seeing here?
Okay, so accuracy is 0.653846, so almost 65% accuracy, I can say. Area under precision is 0.5172, 51% area under precision. Area under ROC curve is 66%. So I still need to understand what
Yes.
is this under precision real cal value and
All right.
this ROC curve. Then F1 score entropy is
Yeah.
99%. I'm happy for
All right.
entropy. Yes.
So-
Entropy is good. I don't know what is entropy, but anyways.
Yeah.
Yeah, it's 99%. So I'm happy. And then log loss is 92%. So it says something lost. So I think it's not
Yeah.
good.
So
I don't know. So log loss is
Yes.
92%. Yeah, go ahead, Alex. I think you will better
No, it's
explain
good.
rather than me
Awesome.
jumping upon these
So you
things.
actually have 65% accuracy. I think Tristan, you mentioned
Okay.
0.65, but it's actually 65%, and that's not great, but not bad. It's your first model, and we didn't include all the columns. I think we can probably get like 82% accurate on this data if we actually played around with it more. The other thing you're seeing here is AOC, so area under precision recall curve, and all of these values, just so you know, should be 1, like or as close to 1 as possible. So the closer to 1 they are, the better they are. There's two concepts here called precision and recall.
Okay.
So what does precision and recall mean?
Mhm.
So that's something that kind of ties straight back into that curve as well that we're seeing, and we're going to have a session on this later where we'll kind of talk about evaluation metrics more.
I'm not able to hear you. Are you
Yes,
saying
I'm
something,
saying something.
Alex?
Can you hear me now, Ravi? Okay, good.
Yeah, I can hear you now.
Yes,
Tell me.
no
You were
worries.
saying
So
something.
precision and recall, those are two important concepts when it comes to binary classification. So precision means that it's what it basically does is that it
Mhm.
calculates how many true positives we have and how many true negatives we have, or false positives. So let's say that a person actually deceased during Titanic, but we predicted that it didn't decease.
Mhm.
So we have a false positive in that case. It wasn't deceased, but we said it deceased, so it's a false positive. So
Okay.
not to go into too much detail here, but
Mhm.
precision and recall kind of measures those curves or
Mhm.
those values. So for example, like let's think here. Take an example when it comes to a credit card firm, right? You get your credit cards and sometimes they get blocked or something. Your bank
Mhm.
blocks your cards because of fraudulent activity or something. And a lot of the time, they
Right,
block your
right.
credit card when it wasn't fraudulent. It could be just that you were maybe in a different city or you were doing
Mhm.
something that wasn't your normal stuff, but it blocked it anyway. And it's not
Mhm.
because it's the machine learning
Right.
algorithm that it does that is bad. It's because it focuses more on, I think, recall than precision. So what it says is that it wants to make sure it doesn't
Mhm.
miss any true positives. It's okay giving some more false positives,
Mhm.
but it doesn't want to miss any true positives. So what I'm saying
Mhm.
here is that precision and recall, they can't both be one. You have to give way to one of the other, I guess, if that makes sense. Anyway, we're going way into the depths here of these
Okay.
metrics. I'm going to prepare a better discussion about this later,
Mm.
so it makes more sense with examples, I think, which will be more fun to walk through.
Yes. Yes.
Cool.
Probably that would be much more better because yes, this is still Okay, so you are saying that accuracy should be like accuracy should be in percentage, and rest of the values, whether this recall curve, ROC curve, all should be near to one, or like it
Exactly, yeah.
should be one or
Exactly,
near to
that's what I'm
one.
saying.
That's what you are
Great.
saying.
So
Okay, so entropy, so it still means that log loss and entropy are almost
they're
accurate.
they're a
They
little bit
are near to
different.
one. So
Yeah,
entropy
so
is
entropy and log
99.
loss are a little bit different. So log
Okay.
loss reduction you want as small as possible. And entropy I actually don't know exactly where we want that one. But
Oh,
those are a bit different. So yeah.
okay.
So before we,
Okay.
I think,
Okay.
wrap
Okay.
this up, I wanted to kind of
Okay.
throw it out there. Like we have a model now, it's 65% accurate. What are some ways we can get this more accurate? Because obviously this is not good enough for production, but it's a good start. Where will we kind of go from here, you think?
Uh, One way would be to try out some other, like, yeah. So if I have to change this thing, probably can we do some changes in our pipeline? Like probably do something like some changes in the, either should we use the
Yeah.
different regression
So
method,
getting
or
getting a lot of great comments here in the chat
uh,
actually right now. Do you want me to read them for you as well?
yeah, sure, because I'm not
I know, yeah.
viewing the chat as
So
of
Tristan
now.
says
So
throw more data at
yeah.
it, and that's exactly a good option. Like if your model is not accurate, a really good way is to find more data and have both more data rows. So the more data rows you
Okay.
have, the better. But also have more wide data sets. So the more features you have,
Okay.
the better. So if you can have more features, is good. And I think Andy also alluded to that, is
Okay.
to like include all the features in the data set and see if that works or not works. T-Love, he pointed out as well that we didn't use a test set, and that's exactly true. What we did right now, we only used the train set and we pretended we had a test set. So what we could do instead is use all the training data to train it, and we can then load the test data as different data view and use that as test data. And that would be the best accurate way of doing this, honestly. But we made it simple for ourselves right now. And then
Okay.
I think
Okay.
Tilo also mentioned that we can try a different algorithm, and that's exactly true as well. What we can do is play around with the transformers here in the trainer. So we could, for example, choose a decision tree or something like that, and we don't need to know too much about what they do, but we can at least try different things here and see if that makes us a better model. And then finally, Andy also said use a smarter way to fill in missing data. Yep, exactly. Or look at the data more and see if there's anything else missing. So exactly. So I guess the point here is there is many ways to, the many roads that leads to Rome, right? And the important thing to know here is
Right.
that we have a way to measure how good the model is, and that's the important thing. We know the accuracy now, and
Okay.
from there we can iterate with different permutations to find a better model that we are happy with.
Okay. Yeah. So yeah, it doesn't give the SIF. This thing, SIF. It doesn't give the SIF automatically. I need to add. So what would be the extension?
.zip.
Train model dot
Yes, that's zip here.
SI.
Yep, zip file, just like a normal zip file.
Yes.
No, it's Z,
Yes.
Z.
Okay. Zip.
Yeah, zip. Sorry. I've
Okay,
learned that
perfect. Okay, yeah, zip
I
file.
learned that the word, the letter Z or Z, is pronounced differently around the world in English. In Swedish it's Z.
Yeah, yeah.
I don't know. In Swedish it's Zeta, and it's like only one way of saying it, and it's no other. But here, like in the US,
Okay.
it's like Z, and
Yeah,
yeah.
Z. In US they call it as Z, and in India it's called it as Z, but we still pronounce it with Z. So it's like zip. So it would be Z. Like when we say Z for zebra, in US you read like Z for zebra. In India we call it Z for zebra.
Yeah.
So we will pronounce it like Z, but we call it as Z.
Cool.
So it's like that,
Yeah.
basically.
That's awesome.
Yeah.
Well, how do you feel? You trained your first model though, Ravi? Not bad, right?
Yeah, not bad, not bad. Thank you. So, yeah, I think it's good. So, yeah. So So probably we need to what one thing would be. Another thing, like after this saving this model, what would be the further use of this model? Save this model. Then what will we do after this? Like how will we utilize this model on?
Yeah. So we can what we can do is we can load it into an Azure function. We can also load it into an ASP.NET Core application, desktop app, whatever you want to. And there's many ways. And the way you will do that is just doing the mlcontext.model.load instead, and then loading the file path from there. And what would happen is you create a prediction engine. It's just an object in mlcontext. It's like one line. And then you pass in the data that you want to use for prediction, and you get back the answer from there. So in general, it's like 4 lines of code to use it, and I think that's a good topic for another episode, honestly.
Probably we'll do what we'll do. Probably we can do that next week, and in the meantime, we can also do that. We can try out different changes in this particular code itself to increase the score of this code. So what we can do is like we can change the parameter. We can add as the suggestions the fellow team members gave that we can add more features to this. We can change this algorithm, or we will try to do the changes and try to increase the metric score. So once the metric score is ready, next week we can deploy this and test it. Probably my suggestion would be, let's do it on local in ASP.NET Core or in Blazor. I'm Blazor guy, so we'll use Blazor.
Sure.
So we can do it in Blazor application, and we'll try to test it.
Yeah. Sounds great.
Yeah.
And there's 2 questions in the chat here. Thilo asked again the use case of the concatenate method. That is on line 26 here. So concatenate, what it does again, like if you think about how this works, there's nowhere apart from concatenate where we define which features in our dataset we are going to use for our model. So the schema, the passenger class, doesn't dictate what features we're using. So maybe you only want to use the passenger class and the age column, and you don't want to use the sex column. What you do then is just leave that out of the concatenate method, and it's going to not use that when training the model, if that makes sense. There are other cases maybe that you want to have multiple columns in your schema, and you want to create calculated variables based on those columns, but you don't want to use all of the columns for your training. So that's a way to specify that in the concatenate method specifically. And what it does underneath the surface is creating a feature vector for you based on those values. And Tristan asked a question here as well. If you get new data all the time that you're testing for production, if the model predicts the correct output, can you input that as new data for the model to learn from? Yes, it makes sense, but only to some extent. You don't want the model to bleed into itself in some ways. So it only makes sense if you can verify to 100% that that's a correct prediction, right? If we are feeding in incorrect predictions into the model, it's going to drift the model and skew it, and eventually it's going to deteriorate and get better and get worse. But what you usually do in production, when you put it in production, is that you monitor the predictions, and you use a lot of that data, and you use a lot of those predictions to feed into your training again next time, right? It's completely true. But you only pick those ones that you are 100% sure that they're correct. For example, maybe you say that a recommender system, and you say, okay, this current client at this website, he or she would like these products. So you recommend them to your clients, but without feedback that that person actually clicked on one of those products, that prediction is worthless. But if your application can feed back and say, okay, this person got recommended these products, and that person also clicked on one of those products, you can then say, okay, this was a really good prediction. Let's feed that into our training data, so next time we'll train this model on that data. I hope that makes sense. So, all right, cool. You're welcome. So, do you want to play around with this model right now, Ravi, or do you want to do that on your own time?
Probably I'll do it on trying fully when I get it.
Yeah, cool.
And I'll upload it. I'll upload this code on my GitHub, and I'll share this GitHub profile along with the YouTube video.
Okay.
And I'll share it with you. So probably you can add it on your YouTube video also. So we can. So whoever wants to try it out, the absolute basic way of using this thing, ML.NET in like creating a model and everything in .NET. So we can try it out and we can go it from there.
Okay, sounds good. Definitely. That sounds great. And Tristan, I can definitely stay around for questions if you have any questions later. I'll be on the stream a bit longer as well. I think that sounds great, Ravi. And I think next week we can do is we can try to deploy this and see to use it as well locally or in an application. And from there we can keep building some other models and get used to these concepts and the ways we're doing this. And one thing I also want to show. Go for it.
Yeah, you were saying you complete it first. I'm sorry.
No worries. What I also want to do is look at Jupyter notebooks with you later and see how you can visualize this data. Because right now we are constricted with a console application, so you can't really get a good idea of the distribution of your data. So that's something I want to do.
Okay, yeah, we can do that. We can do that thing. Before logging off, one question I would say, not one question, probably I'll write it notes. So like we can write it this like note for practice. We can say steps to increase the matrix, like what was the matrix score, we can say, right?
Metrics with an E, so metrics.
Okay, M-A-T-R-E-X.
E-E-C, M-E-T-R-I-C-S.
Oh, okay.
Yeah.
Okay, M-E-T-R-I-C.
Metrics.
I'm sorry.
Yeah.
I'm using this.
It's an international stream, you know.
Yeah.
Swedish person, Indian, US.
Yeah, people from US and India are joining in. And then steps to increase the metrics score. So number one is, like, of course, add more data, which is like we need to check.
Yep.
We need to check if it is available or not. Anyway, we have data. Number two would be like separate test data.
Yeah.
Separate test data. Okay. And so if we go with the route of taking separate test data, so in that scenario, like here we'll use test data. So this test data will use another file, right?
Exactly.
So you want.
So you won't split the data.
Yeah.
In that case, you won't split the data. What you will do instead is just have another data load. So you on line 16, you will duplicate that row, and you will point it to the test data file instead. If that makes sense. That's the easiest way of doing that, I think.
So come again, please. You were saying in line 16, data will be one, and then after that we'll create another like test data, like load from.
Yep.
So here, where we will keep it test data? Is there another field called test data?
No. What you would do is just load the test data into a new test data view. You won't split the data, but otherwise it's the same. So you would remove line 19 to 21, and you will just duplicate line 16 and call it test data and load from test.csv. That's the way you would do it if you want to do that.
So will it be in the same ML context, or will it be a different ML context?
The same ML context. That'll work just fine.
Okay.
But yeah.
Okay, we'll let me check it out.
Lay down.
Okay, so take a separate test data. Another suggestion somebody gave, use different algorithm.
Yep.
Algorithm. And what was the next suggestion? Let's
Yeah.
note it down probably.
Use all of the features, I think. Use more features. So we didn't use all the
Okay,
features.
use all the features. Yeah, that was the one. So this would be the simplest one, I would say.
Yes.
Yeah, this would be the simplest one.
Exactly, yeah.
Simplest one. Yeah, and again this would also be the simplest one, but anyways, we'll write it down. So yeah, so okay, so so what I'll do, I'll check in this thing, and it's like ML for beginners. So I'll check in this thing on my GitHub. I'll share the link with you on Twitter pretty soon. And when you print it, when you publish it on YouTube, you can share it, and you can share me the file, and then I'll publish it
Cool.
there on my YouTube.
That's awesome, Ravi.
Cool.
Well, thank you for today.
Okay.
I will stick around for some questions for everyone on the stream, but thank you, Ravi, and I think we'll talk to you next Saturday.
Yeah. Thanks a lot, Alex, for doing these sessions for my user group also. So thanks everyone for joining. We'll see next week, and hopefully we'll deploy this next week on a Blazor application, and we'll run this thing. And in the meantime, I'll also look out for options to run this thing on Mac, or try to do it with Visual Studio Code if I can do it. So let me find out the ways to do this thing in Visual Studio Code.
Cool. Awesome, Ravi. Have a great day.
Okay.
Bye.
Thank you. Bye. You too. Bye.
All right, everyone. How are you doing? I'm going to stick around here with you for some questions here. And now we have the chat open and going as well. So you have some data, Tristan, that you want to look at. We got some music going here. So let me look at you. Ooh, that's interesting. Let me look at your data, Tristan. I haven't worked too much with image classification, to be honest. But I know Daniel on the line here as well is a great resource for ML.NET. So he may be able to use or help you. But let me share my screen here, and we can look at the data together if you want to. I think that's a good way of doing this. 1 second here. So, all right. So you have this data set, right? So what do you want to do, Tristan, with this data? Can you explain your use case here? You want to, I guess, figure out the numbers? Yeah, 1 to 9. So I think what you can do here is you would need to have labeled data first of all. I'm not sure if this is labeled or not, but this is a classic example of, okay. So how many of number 6 do you have here? I guess this is 6, 3. So you need, first of all, you need to have multiple pictures with the same number and then labeled. And then what you would do here is use image classification for this. And you can definitely do that in ML.NET, not a problem at all. And there are some good examples of doing this. Let me open up a notebook for this. This is kind of outside of today's stream here, so I won't spend too much time on this, but I do want to at least put you in the right direction. Thanks, Andy. I'll catch you next time. Alright, you have a lot of images. So you can definitely do this. And we'll open a notebook here that I have. Let's see. So Interact is open source editor for like Jupyter Notebooks. And not to go into the details too much here, but what you can see here is we're doing the same thing we did with Ravi just earlier here, but we're doing it in a notebook instead. And what I'm doing in this case here is kind of similar to what you're trying to do. It's not the same thing, but I want to show you kind of the similarities. And let me open the data to show you. Because what we're trying to do here is a source. 1 second here. Data sets. Okay. Let's get that over. Let's remove some of these things here. Okay. So in this example right here, I have tons of pictures here of categories of things, right? So we have different types of clothes. We have men's shirts, and we have backpacks, and we have so forth, different things here, right? So similar things to what you're trying to do here with the numbers, right? They're the same kind of thing. The difference here is that I have my labels in a CSV file. You probably have the same thing where you load in as a CSV file. But this is the same kind of problem you're trying to solve. What you would do then is just kind of define the image data, and the image data would be a path to your image, so that would be a path to each number, so like number 6 or in different permutations. And then you would say label, so label would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, no matter how you have. And then what you would do is kind of create a method like this, get images. So you would create these image data classes where you have your label, which is the number, and the path to that file. And the ML.magic has to do with 2 things. The first thing, of course, is just loading the images from an enumerable like this, shuffling it, and then what you would do then is doing something similar to this, where you would load the raw image bytes like this, and this is just transforming the pictures to pixels, and you will fit that. But then what you would do here is this right here. This is kind of the secret sauce. This is where you are using a neural network and transfer learning to take an image and fit those pixels into a label that you want it to be. And in our case, that will be the ML context. It will be multi-classification because you have multiple choices, and then image classification as an option. And you will pass in these things. It will use TensorFlow under the surface, and we'll train it. And I won't dive too much into the topics here, because I think what you can do instead is have a look yourself. I already have a repo open for this. So if you want to kind of play around with this yourself, you can go to my GitHub and then -m_on_Jupyter, and you can have a look yourself. And it's going to be under the data view options here. The notebook I have open right now is called image classification right here. And if you open that up in like Interact, I will just kind of give you that as well. Maybe that's not it. Yes, this one. Something like Interact.io, or you can just copy the code straight from this one into Visual Studio Code. That should be able to give you what you need to do this task at least. So I hope that helps. Awesome. All right, Tristan. Any other questions on the stream today before we call it a day here? Jupyter Notebooks works in Visual Studio Code actually, but what I was suggesting was actually to just copy the code straight into a Jupyter, like into a console application instead. So if you don't want to like add support for Jupyter Notebooks on your machine, which I completely understand, you can just take the C# code from these Jupyter Notebooks and put them into a console application of your choosing instead. And that should do it. But that's a great question. All right. Well, I just want to thank you all for joining the stream today with me and Ravi. It's been lots and lots of fun, and thank you for following us on Twitch and Twitter if you think this is interesting. If you have any questions, don't hesitate to reach out to either of us at any point in time, and we're happy to try to answer those questions. And I will send the link into the chat. That's a great suggestion, Tristan. So you and others can have a look if you want to. There you go. All right. Well, I will be online on Tuesday again next week. We're going to talk about MLOps.net. So we're going to talk about more about using MLOps for ML.net. And next Saturday, me and Ravi are going to go back into looking at this. So thank you all. Have a fantastic day, and I'll talk to you next time. Goodbye.